right, welcome everyone. We're really excited to have you join us today for this Built for Shopify session focusing on admin performance. I'm Cameron Barker. I'm a senior staff developer here at Shopify, and I'm thrilled to be joined by Jonathan Zazoff, Director of Product, and Jamie Perlmutter, Senior Data Scientist for the Built for Shopify program. Today, we've got an action packed session where we'll share some valuable insights, hands on tips to help you boost your app's admin performance, tackle common Web Vital challenges, and ultimately set you on a path to achieving Built for Shopify status. Let's walk you through what's in store for today. Jay-Z will kick things off with an overview of what the Built for Shopify program is, why we created it, the benefits for both app developers and merchants, and what it takes to get certified. Next, Jamie will dive into the core performance benchmarks we focus on, why they matter, how they're measured, and how they tie back to the real-world merchant experience. Then I'll return to walk you through the new performance monitoring tools and debugging tools we've introduced, followed by some practical strategies to improve Web Vital metrics and help you fine-tune your app's performance. Finally, we'll cover some of the most common performance issues and questions that we see that affect the user experience in Shopify's apps related to Web Vitals. We're so excited to bring this session to you today. So without further ado, I'll pass the mic over to Jay-Z to get us started.
Thanks, Cameron. Before we dive into the practical steps of improving admin performance, I want to take a moment to give you a quick overview of the Built for Shopify program and explain why we're so committed to holding apps to such a high standard. Our collective goal is to empower merchants to attract more customers, craft beautiful storefronts, and boost their sales. However, merchants can't achieve these goals if they're burdened with software that's slow, confusing, or clunky. Success is a shared goal. While we at Shopify focus on building the platform, it's all of you who bring it to life by developing apps. Together, we can create the tools that drive merchant success. At Shopify, we're eternally committed to great software. We believe that great apps deserve to be recognized and rewarded. Built for Shopify is our way of doing that. So what do apps get as part of Built for Shopify? App Store badging, search boosts, promotion, and plan targeting. Apps with the Built for Shopify status see accelerated growth with an average increase of 50% new installs in just 14 days of achieving status. Okay, so you all understand the benefits of Built for Shopify. So let's talk about how Built for Shopify stands for great software. There's no one thing that makes software great. We've established 3 pillars that we think make great software: integration, design, and performance. Today, we're going to specifically focus on performance. Every surface matters. That's why we look at both performance for buyers as well as merchants. On storefronts, quick page loads reduce buyer frustration and cart abandonment. And fast admin pages let merchants focus on selling instead of waiting for apps to load. Storefront performance leverages Lighthouse for testing. We compare storefront performance with and without your app installed. This allows us to understand the impact of your app to pages like product details, collection pages, as well as the home page. We test with our default theme, Dawn, installed. Admin performance is based off live user data from actual merchants using your app. We use the Web Vitals package from Google to measure 3 metrics. Now I'm going to pass to our data scientist, Jamie Perlmutter, to go into the details of admin performance and how we measure them.
Hi, everyone. I'm Jamie Perlmutter, a data scientist here at Shopify, and I'm here to walk through the specific metrics that we care about within admin performance, why we care about them, and how they're measured. There are 3 core admin performance metrics that are part of the BFS standards, each reflecting the experience merchants encounter many times throughout their day. These 3 web vitals are Largest Contentful Paint, also known as LCP, Cumulative Layout Shift, CLS, and Interaction to Next Paint, INP. We'll dive into each individually, but every web vital is measured the same way. Firstly, we require a minimum of 100 calls in the last 28 days to make sure we have a stable evaluation of the metric. We don't want anyone penalized for bad merchant internet or other issues that could impact the results. And to evaluate, we take all calls in the last 28 days and use the 75th percentile of performance as recommended by Google. Now, to dive into the individual Web Vital metrics that we look at, the first one we're going to talk about is Largest Contentful Paint, also known as LCP. And this is really a measure of how quickly your app loads. More technically, it's how we report on the render time of the largest image, text block, or video visible in the viewport. No merchant likes slow loading apps, especially for the core functionality of the app. This metric helps us isolate the loading performance of what is typically the page's main content. Our standard for LCP is set at under 2.5 seconds to load that content for 75% of app loads across all merchants. This metric has existed in all iterations of BFS, and the standard has remained the same throughout. Our next Web Vital is cumulative layout shift, also known as CLS, and it's a calculation of how stable your app's UI is. It specifically takes the largest burst layout shift scores for every unexpected layout shift on a page. No merchant wants a button to jump out of the way when they're about to click it. This metric helps us measure how stable your app's UI is, a key component of the merchant experience when using your app. The layout shift score is calculated by taking the impact fraction, so the fraction of the area of the viewport that is actually unstable, multiplied by the distance fraction, meaning the distance the unstable element has actually moved. Our standard for CLS is set at under 0.1 for 75% of app loads across all merchants. This metric used to exist in early BFS days and now is being brought back for the newest iteration. Our last Web Vital here is Interaction to Next Paint, also known as INP, and it evaluates how responsive an app is. Specifically, it looks at the responsiveness of an app to user interactions through the latency of all click, tap, and keyboard interactions. No merchant wants to wait for results after a button click or a keyboard entry. This metric helps measure how responsive your app is, a key component of the merchant experience when using your app. Our standard for INP is set at under 200 milliseconds for 75% of app loads across all merchants. Now, I'll pass it over to Cameron, who will take us through tooling and debugging strategies to improve your app's admin performance.
Hey, thanks, Jamie. All right, it's my pleasure to walk you through the new tooling we've introduced for monitoring and debugging app performance in Shopify apps. Today, we'll focus on how these tools can help you ensure your app performs optimally by leveraging Web Vitals. Let's dive into the first tool, monitoring. So monitoring can identify performance issues as they occur. It enables timely optimizations. This proactive approach can significantly enhance the user's experience and lead to higher adoption for your app. To get started monitoring app performance, your app must be using the latest version of AppBridge. The great news is that this is as simple as connecting to our CDN source, and you can quickly enable Web Vital monitoring without any complex setup. We'll initialize AppBridge by setting our API key, which can be done automatically by including the symbol shown in the slide. Now that we have AppBridge set up, we can access performance metrics directly with our app with minimal effort. Let's examine this implementation. All right, so this code snippet is an example of what you'll add to your app. In this code, we define a callback function called process Web Vitals. This function receives Web Vital metrics and allows you as a developer now to have access to the metrics that Shopify records now in real time. We will register the callback utilizing AppBridge global configuration variable. Let's break it down just a little bit further. The first callback function with the callback function, this function receives the metrics object, which includes vital information like app ID, shop ID, user ID, and array of metrics. I'm in this example sending it all to my backend server using the Navigator send beacon method, and this will allow us to send it through the termination of pages. And once we get it, we can store it and analyze it. Now that we understand the implementation, let's switch to a live demo to see this in action. All right, first let's ensure that AppBridge is installed. This app was generated by Shopify CLI, which creates a new remix app that already includes AppBridge and connects it with your API key. If you aren't using the Shopify generated remix app, you'd want to add the AppBridge library to your app's header section. All right, once you have it connected, I usually recommend running Shopify app dev, which starts our app in production. This is just to confirm that the app that AppBridge is enabled. Let's wait for this to start. All right, it looks like it's ready. I'll go ahead and press P to open the app. Now that the app is open, let's open our development console and confirm that AppBridge's global Shopify object is available. To do so, we'll simply type Shopify into the console and confirm an object is returned. It looks like it is, and so we're all ready to start implementing our monitoring. Let's jump back to the code. All right, I want performance monitoring to be present across all of my pages, or at a minimum, any page a user might initially land on. To do so in my app, I'll navigate to our app folder and to the root.js X file, which acts as the layout for our application. Because we're in a remix app, which is rendered server-side, and we want to ensure we have access to the Shopify global variable in the client, I'll add useEffect and implement the monitoring there. Next, let's implement our callback function to send the metrics to our server. We're going to create a function called processWebVitals that accepts metric data. First, let's prepare our data to be sent to our server by turning it into a JSON string. Next, let's specify server URL that we want to send this data to. In this case, I'll use request bin to allow us to capture the post request and review the body contents. Lastly, I'll use Navigator's Send Beacon feature, which is the recommended approach for sending analytics during a page's termination. Now that our callback is ready, let's go ahead and connect this to our on report by adding Shopify Web Vitals on report and passing the function. Before we run this, one optimization that you might want to consider is sending a page identifier along with the metrics to ensure that you're optimizing the correct page. All right, jumping over to our app, it's already been refreshed for us thanks to Shopify Dev's hot refresh. So our changes should be already in effect. Let's go ahead and trigger a generation of a new product to add some interaction performance metrics to this page. The callback will be triggered when a user navigates to a new page, either within the app or to another location in Shopify's admin. So I'll go ahead and navigate over to our home page to trigger our metric capture. Now let's change tabs to our request bin to confirm we're seeing the metrics come through. It looks like it has, and by clicking on the post request, we can inspect the payload. Let's talk through a few of these fields. The app load ID can be used as a unique identifier for the event. We've also included the shop and user here, which can be used to identify edge cases caused by shop-specific data or even users' connections. Lastly, we've included the Web Vital metrics and their values as an array of objects. We recommend that any app seeking built for Shopify status record and monitor these metrics. As Jamie mentioned, we measure over a 28-day window, and so we recommend you retain the data for the same period of time to ensure that you have the data needed to resolve any concerns merchants or Shopify might flag. This concludes the implementation of monitoring. We're so excited to get this into your hands.
All right, next, let's look at the new debugging tools we've introduced to make finding performance opportunities even easier. Shopify now provides two new tools for debugging app performance. One focuses on providing the metrics Shopify utilizes in BFS, and the other provides access to raw web vitals that are generated by Google Chrome's Web Vital package. Working together, these tools will help you find opportunities to improve your app's performance. To start debugging your app performance, your app must use the latest version of AppBridge, similar to monitoring. We'll also need to set a new configuration key in the global Shopify configuration named debug and set its content to Web Vitals. This can be done a few different ways, but my preferred way is just to set a meta tag as shown here. Once we've had this flag enabled, we'll start to see two new types of messages in our development console. This one's the first one. To make it easy to understand the page's overall performance, we output the same metrics shared in the monitoring tool in the console here. This feature can be used to confirm that the performance improvement you've made will actually aggregate to Shopify. We've also included raw Web Vital metrics that Chrome's Web Vital package generates during the page's lifecycle. These metrics will be logged on load during interaction and navigate when you're navigating away from the page. In many cases, you'll see duplicate metrics. It's valuable to align the raw metrics you're seeing here with the final metrics Shopify records, which you can see in the console using the other tool. All right, let's jump into our code base and try out these new debugging features.
First, let's start by adding the meta tag to enable these debugging features in our app. This consists of a meta tag with the name of Shopify Debug and the content of Web Vitals. Now that we have our meta tag implemented, let's confirm it's working by reloading the app and confirming we're seeing the metrics from Chrome's Web Vital package coming through in our console. Nice, we're seeing them come through. There can be a lot of noise in the console, so we can go to the debug filter to get a cleaner view of the raw Web Vitals. Let's inspect one of the metrics. Here we can see the metric name, value, a rating, and an array called entries, which has a record of elements affecting the specific metric. This array can be helpful when trying to spot which element might be causing your page's performance issues. You might have noticed some duplicate metrics in the console before, and I'd like to understand which metrics Shopify will actually record. This is where we can utilize Shopify's recorded metrics output. It's important to remember that Shopify records metrics during navigation within or away from the app. So to trigger the metrics, we have to navigate away from this page. Before I do that though, seeing as these results will be from this page's experience, I want to ensure that I've preserved the logs between the pages. To do so, in my development console, I'll go to the settings by clicking this gear and ensure that preserve log is checked. Now with this enabled, let's navigate away from our page. All right, so I'll scroll up to home and navigate away. Great. All right, let's clear some of this away. Let's go. Great. All right. We now see a table in our console that includes the metrics that Shopify captured from our app. These metrics are the same as the data that is shared with the monitoring callback, so this can provide a convenient way to confirm that the performance improvements you have made will affect the metrics that Shopify records. Again, because there can be a lot of noise in the console, you probably noticed we've put this metric underneath the info tab in the dev console. One gotcha that you should be aware of is that we need a fresh instance of your app to return these logs. So in some cases, you might run into a scenario where you've captured the metrics already, made some changes, and when you go to trigger this log by navigating to a new page, nothing shows up. This is simple to resolve. All you need to do is clear the cache by doing a hard refresh. With this done, you should be able to see the recorded metrics again when you navigate away from the page. With these debugging tools, you now have the necessary means to find opportunities for performance improvements in your app. And it was as simple as adding a meta tag to the header of your app. This will conclude the implementation of Web Vitals. We'll send it back over to Jamie to take us through common performance issues.
Tooling is just one part of the debugging experience when improving performance. It's also important to understand what actually causes these issues. While I won't be able to provide a holistic view of what can cause performance degradation, I did want to discuss some of the common performance issues that we see affect the user experience in Shopify apps. First, let's start with LCP. To reduce LCP, focus on these three strategies. First, optimizing images by resizing and compressing images using modern formats like WebP. You can drastically reduce file sizes without sacrificing quality. Additionally, consider using CSS effects to replace images when possible, which can improve loading times. Second, prioritize critical asset loading by utilizing the preload attribute on key resources to ensure the web page prioritizes resources essential to the elements above the fold. Third, optimize server and CDN usage. Improving your server's response time and leveraging a content delivery network, CDN, to reduce latency ensures that your content is delivered quickly to users regardless of their location. To reduce CLS, focus on these strategies. First, include size attributes for media by specifying width and height for images and videos. This helps the browser allocate space for these elements before they load, preventing shifts. Second, manage content and fonts by avoiding content injection above existing content, which can cause unexpected shifts. Also, preload essential fonts using font display swap to ensure text remains visible while fonts are loading. Third, handle animations very carefully. We recommend when using animations, utilize transforms over layout triggering properties. This helps maintain layout stability during transitions. To optimize INP, consider the following approaches. First, optimize JavaScript execution by breaking up long tasks into smaller chunks and deferring non-critical scripts. This ensures that the main thread isn't blocked, allowing for quicker responses to user inputs. Second, use web workers. Offloading non-UI work to web workers frees up the main thread. Additionally, prioritize input handlers and implement throttling or debouncing to manage rapid input events effectively. Third, similar to LCP, optimize asset loading. Preload important assets that are critical to the first interaction and lazy load non-essential ones to improve the initial loading experience.
Thanks, Jamie. We've only scratched the surface of improving your app's performance here. If you're interested in learning more, you can access our resources via the Built for Shopify Resources Hub in the .dev community forums. That brings us to the end of our session. Thank you so much to our community for joining us and diving deep into admin performance with Built for Shopify. We hope the insights and tools we shared empower you to take your app's performance to the next level and meet the Built for Shopify standards.